Welcome, dear listener, and good evening, or perhaps good early morning, depending on when you've found this quiet corner of the internet. You've arrived at Boring Science for Sleep, a place where science doesn't shout, but whispers, softly, steadily, like waves rolling in beneath a sleepy sky. Here, we don't rush to explain. We drift gently through wonder. We trace the outlines of the universe in slow motion. And tonight, you're invited to let the world slow down with you. So, settle in. Find your most comfortable position. Let your body soften and your breath settle like silt on the sea floor. Where are you listening from? And what time is it there? It's always comforting to know that across this vast planet, others are drifting too, letting go of the day, welcoming rest, guided by curiosity and calm. Because tonight, we're slipping quietly into one of nature's most elegant dances, a story of invisible pulls and ancient rhythms. We're going to explore how the moon moves the sea. Every day, without a word, the moon reaches across space and gently pulls on our oceans. Not with force, but with persistence, with patience. It's a cosmic lullaby, and it's been playing for billions of years. So as your thoughts begin to settle and your limbs grow heavy, know that you are not alone. The same moon that rises over your window is pulling on the tides right now, just as it always has. And if you're ready, we'll begin our slow drift into this story. The story of how the moon quietly holds the oceans in its sway, and how that same rhythm might just carry you into sleep. Let's begin with stillness. Imagine a calm sea under a night sky. No wind, no waves, just a vast, mirror-like surface, stretching endlessly toward the horizon. But even here, in perfect silence, something is moving. Something deep and slow. Something you might not see, but that's always there. The ocean is never truly still. Even on the calmest night, beneath the surface, the water is rising or falling, not because of a storm, not because of a boat, but because of something far, far away. Something suspended in the sky, quiet and glowing. The moon. You've seen the tides, perhaps without thinking much of them. Water creeping up the beach, then slipping away again. Rocks that vanish beneath the surf by afternoon, then stand bare by nightfall. Fishermen and sailors learn to respect this rhythm. Children building sandcastles learn to race it. But what is it, really? This great inhale and exhale of the sea? For centuries, people puzzled over the tides. Some believed the ocean was alive, breathing in and out. Others thought it was the sun's doing, or even the will of the gods. And in a way, those guesses weren't so wrong, because while the science would come later, the mystery was always present. Even now, when we can explain it with diagrams and formulas, there is still something deeply poetic about the way the moon pulls the sea. It's not a shove, not a jolt, but a tug, gentle, patient, continuous. The moon doesn't touch the ocean. It simply pulls on it from a distance of nearly 400,000 kilometers. And the ocean, so vast, so heavy, responds. It rises. Twice a day, in places all over the world, the sea moves in and out, in rhythm with the moon's passage overhead. It's as if the water listens, as if the earth itself listens. The tides are not chaos, they are coordination, and the rhythm is not just daily, it's ancient. For as long as the earth has had oceans, the moon has pulled on them. When trilobites crawled across seafloors, the tides came and went. When dinosaurs roared across distant beaches, the moon still called the waters back and forth. And now, as you lie here, letting your own breath come and go, the ocean continues to move. To that same familiar tune, you and the tides are both obeying gravity tonight. But here's the curious part. Why water? Why does the ocean move while the land seems to stay still? That's something we'll explore more in the next segment. But for now, just know this. Water listens differently. It yields. It flows. It bends to what calls it. And that's what makes the tides so magical. They are not just a fact of nature. They are a response. A relationship between Earth and Moon, between mass and movement, between something grounded and something distant. And perhaps, as you lie here tonight, you too are part of that rhythm. Your body, mostly water, your heartbeat, a steady pulse, your breath, like the waves. Inhale and exhale. Maybe you don't feel the moon's pull, but your oceans do, and that's enough. The world is vast, the sky is quiet, and the sea is listening. So rest now. We've only just begun. There are more mysteries to drift into, more tides to follow. The moon is still watching, and the ocean is still moving. Imagine yourself floating, not on water, but in space, alone, still. Above you, no up. Below you, no down. Just stars, silence, distance. And then, from far away, something begins to pull. Not a force you can see, not a wind, not a shove. Just a soft invitation, a pull so constant, so invisible, you might not even notice it unless you paid close attention. That pull is gravity. It's the same force that keeps your feet on the ground, that brings the rain back to earth, that shapes stars and keeps the moon so distant, gently circling our world every night. Gravity is not loud. It doesn't crackle or spark. It doesn't demand. It whispers. It invites. It waits. And perhaps no gravitational relationship is more delicate, more poetic than the one between Earth and Moon. You see, the moon isn't just up there. It's not hanging like a picture in the sky. It's falling endlessly, gently, sideways. And Earth, in return, is holding it close. Not with arms, but with mass, with gravity. It's a cosmic waltz, a dance choreographed by physics, but performed with elegance. Now, let's come back to the ocean, to those waves that rise and fall with each passing hour. How does the moon, so far away, pull something as vast and heavy as the sea? How can something suspended in the sky reach down to touch the water beneath our feet? To understand that, we need to feel just how far and how constant gravity really, Island. Let's take a journey. From here to there. The moon is about 384,400 kilometers from Earth. That's almost 1 million times the height of a tall building. More than 30 Earths could line up between our planet and its satellite. And yet, even at that distance, the moon's gravity moves entire oceans. That's because gravity never turns off. It never stops at a certain range. It just gets softer, quieter, more subtle, like a whisper heard across a canyon. The moon pulls on every atom of Earth. Yes, even on you. But Earth is massive. It holds itself together tightly. It doesn't shift easily. Water, though? Water listens differently. Water yields. It's soft, responsive. It moves when asked, especially by a pull as patient as the moon's. So as the moon glides overhead, its gravity reaches down and begins to stretch the ocean beneath it. It pulls the sea slightly forward, just a bit, enough to make it bulge, not dramatically, not like a mountain rising, more like a gentle swell. And that bulge? That's high tide. But here's the strange part. That bulge doesn't stay directly beneath the moon, because Earth is spinning too. So the ocean bulge is constantly being pulled forward, chased by the moon's gravity, never quite catching up, like a ribbon caught in the wind, always flowing, always pulled. And remember, the moon pulls not only on the near side of Earth, but on the whole planet. That means there's another bulge. On the far side, a kind of echo, caused by the center of the Earth being pulled more than the distant water. So we end up with two tides, one on the side facing the moon, and one on the opposite side. A double rhythm, soft and slow, rising and falling, as the moon completes its orbit. But even that is only part of the story. The sun also plays a role. So does the shape of the coastline, the depth of the ocean, the slope of the seafloor. It's a symphony of forces, but the moon is the conductor. Let's pause here. Take a slow breath. Feel your own weight on the bed. That's gravity. It's holding you gently, just as it holds the sea, just as it holds the moon. Einstein taught us that gravity is not just a force, but the bending of space itself. Mass curves the fabric of reality, and objects follow those curves. So, in a sense, the moon is not pulling, it's curving space, and the ocean is simply flowing along that curve. It's like a marble rolling around in a bowl. It doesn't choose to curve, it simply follows the path laid beneath it. This means the moon is constantly reshaping the world, not through violence, but through grace, through subtlety. And that's what's so beautiful about it. The moon doesn't need to shout to shape our shores. It moves us quietly. Like so many things in life, the forces that affect us most are often the ones we barely notice. The things that shape us happen slowly, gently, repeatedly, and eventually we adapt. We form new shorelines. We learn to rise and fall without resistance. So as you rest here tonight, perhaps you can feel that softness, that grace. You are being held by invisible forces, not just gravity, but memory, emotion, connection, things you can't always see, but that shape you nonetheless. And just like the ocean, you are allowed to move, to yield, to respond. Not all motion needs to be loud. Not all power needs to be visible. Sometimes, the strongest pull comes from far away and moves you in ways you only notice when you stop to feel it. So let yourself drift like water beneath the moon. Let the tides carry you. Let gravity hold you. And know that even now, as your eyelids grow heavy, as your breath grows slower, the moon is still watching, still pulling, still guiding the oceans, and perhaps, gently, you too. Let's begin, not with the sky, but with the shape of the earth beneath your feet. You might imagine Earth as a solid blue marble, firm, spherical, and unchanging. But in truth, our planet is far softer than it appears. Not soft like a pillow, but soft in the way a breath fogs a window, momentary, shifting, delicate if you know where to look. If we could peel away the forests and cities, the oceans and clouds, and look down at Earth from space, we'd notice something subtle, something surprising. Earth is not a perfect sphere. It bulges gently at the equator, pressed outward by its own spin, flattened just a little at the poles. It is, in technical terms, an oblate spheroid, a shape shaped by movement, but more than that, Earth is a body in motion, and in response, it stretches, it sways, it listens, and of all the materials on its surface, stone, sand, forest, snow, none are more responsive than water. Water is nature's great listener. It yields before it resists. It flows around obstacles instead of breaking them. It carries the shape of the container, but never forgets its own nature. And so, when the moon stretches its invisible hand across the planet, calling softly through gravity, it is the water that answers first. The land stays mostly still, rigid, slow to respond. It too is pulled by the moon, but only slightly. You wouldn't notice the movement under your feet, but the ocean, it listens with its whole body. Let's imagine Earth again, this time as a sphere covered in a thin, shifting shell of water. Not as deep as you might think. The average ocean depth is just about 4 kilometers, compared to Earth's diameter of over 12,000 kilometers. A paper-thin layer, in planetary terms. But this thin layer is alive. It feels the pull of the moon and stretches into shape, not once, but twice each day, once on the side facing the moon, and again on the far side, where centrifugal force creates an echo of that pull. We think of tides as waves, but they are not like the ones that crash on the shore. They are not caused by wind or storms. They are bulges, slow, planetary-sized swells that move across the globe as the Earth rotates. And that brings us to an even subtler point. The Earth is not just round and rotating. It is rotating underneath the bulge. That is, the ocean isn't sloshing back and forth. The tidal bulges mostly stay in place, and Earth spins beneath them, so that from any given beach, the tide appears to come in and go out. It's not the water that's hurrying toward you. It's the whole planet turning slowly beneath the moon's touch. The moon's gravity doesn't lift the ocean straight up. Instead, it stretches it outward, like taffy, like silk pulled taut. This stretching motion is only possible because water allows it. Imagine trying to stretch a mountain. It would crack, resist, break. But water? It flows. It bends. It absorbs motion, then passes it on. And here is the quiet beauty of this segment, a thought you can carry with you as you rest. The moon doesn't just move the tides, because water is liquid. It moves the tides, because Earth is tender in the right places. Our planet is not a cold, unfeeling rock. It is textured, responsive, full of soft edges and moving parts. It is the combination of water's softness and gravity's patience that creates the tides. Without that softness, no pull would be enough. And without that pull, the softness would go unnoticed. Maybe there's something deeply human in that. We move, too, when something touches us, not always forcefully, but with subtlety. A kind word, a memory, a voice. We shift our emotions like tides, sometimes high, sometimes low, depending on the forces around us. And like the ocean, we don't always understand why we feel the way we do. We only know that we're being moved, stretched, held. Now, back to the planet. You might wonder, why doesn't all the water move? If the moon is so powerful, why do some places have tiny tides, and others see the sea rise meters high? That depends on many things: the shape of the coastline, the depth of the water, the width of the ocean basin. It's like shaking a bowl. A shallow bowl reacts differently than a deep one. A narrow bowl may spill, while a wide one ripples calmly. Earth's geography creates countless variations, but the moon's invitation remains the same. Every coastline receives the call. Every drop of water feels the shift. In some places, the response is quiet. Elsewhere, it's dramatic, but always, it is graceful. Because gravity is a sculptor and water is its clay. Let that thought settle into your breath. Let it soften your jaw, your shoulders, your stomach. Like the ocean, you are shaped by gentle forces. Not everything that moves you needs to be loud. Let that be your comfort tonight. You don't have to push. You don't have to fight. You can respond. You can yield. And in yielding, you may find strength. You may find rhythm. You may find peace. As you rest, remember this. The sea does not resist the moon. It rises, and it falls, and it continues, always. You can do the same. So breathe in like the tide rising, and exhale like the tide returning to sea. And as we move toward the next part of our journey, remember, the reason tides exist is not just because the moon is strong, but because Earth knows how to listen, and water knows how to move. Why does the tide come in and then go out twice a day? It seems almost counterintuitive. The moon moves slowly across the sky, so shouldn't the ocean respond once? A single pull, a single rise. But as with many things in nature, the answer is more nuanced and far more beautiful. To understand the rhythm of the tides, we need to think not just in terms of space, but in terms of motion, in terms of relationships, in terms of balance. Because when the tide rises and falls twice a day, what you're really witnessing is a quiet dance between gravity and inertia, between the moon's soft pull and the Earth's steady spin. Let's return, for a moment, to the image we held before. The Earth as a sphere, gently wrapped in a thin layer of water. Now, imagine the moon overhead. Its gravity reaches across the void, gently tugging on that watery shell. As it pulls the water nearest to it, that portion of the ocean bulges slightly outward, forming what we call the direct tidal bulge. That part makes sense. The moon pulls, and the sea rises to meet it. But what about the opposite side of the Earth? The side facing away from the moon? Strangely, the ocean bulges there too. Another tide, rising at the same time as the one on the side closest to the moon. Two tides, one facing the moon, one facing away. Why? To answer this, we must consider a concept not often associated with bedtime stories: centrifugal force. But don't worry, we'll whisper it to sleep too. You see, the Earth and the moon aren't just still in space. They are actually orbiting each other. Yes, the moon goes around the Earth, but technically, they both orbit a shared center of mass called the barycenter. This point lies about 1,700 kilometers beneath the Earth's surface, not exactly halfway between them, but a sort of gravitational balance point. As the Earth and Moon orbit this shared center, the Earth experiences a subtle outward force. On its far side, the side opposite the Moon, it's a bit like swinging a bucket of water on a string. The water presses against the outer side of the bucket, not because it's being pulled, but because it wants to continue moving in a straight line. This same effect, when applied to the Earth's oceans, creates the second bulge. So while the side facing the moon is drawn outward by gravity, the opposite side is nudged outward by inertia, a kind of trying to keep going force, as Earth spins beneath the moon's influence. Together, these two effects, gravitational pull and centrifugal response, stretch the ocean into an oblong, double-bulged shape. And as Earth rotates beneath this watery ellipse, each spot on the globe passes through both bulges every 24 hours and 50 minutes. That's why you experience two high tides and 2 low tides each day. One tide from the pull of the moon and one from the gentle outward lean on the opposite side. Now take a moment. Breathe that in. This rhythm, twice a day, every day, is older than any calendar, older than writing, older than coral reefs or rivers. It's a rhythm carved into the bones of the planet. And it continues, no matter who watches. It continues right now, as you lie here, perhaps listening to the distant hush of traffic or the quiet breath of someone nearby. The ocean, somewhere far from where you are, is swelling and slipping away. And it will do so again in about 6 hours. And again after that. This constancy, this certainty, can be a comfort. In a world full of surprises and noise, the tides remain a quiet truth. Now, let's imagine what it would feel like to stand in one place and watch it happen. You wake in the early morning. The beach is wide, the water distant. As the day unfolds, the sea slowly creeps forward, curling around rocks and toes of sand. By afternoon, it is high, lapping at the dunes, swirling near the boardwalk. Then, as shadows lengthen, it begins its retreat. Soft, slow, like a sigh. But before the night is over, it begins again. Another rise, another fall, 2 tides. Every day. Always. But this isn't true everywhere, you might say. And you'd be right. The ocean doesn't behave the same in every place. Some coasts see only 1 high tide per day. Some see wildly different tide heights between the 2 daily cycles. Why? Because Earth, like all good storytellers, adds variation to its rhythm. The shapes of coastlines, the depth of ocean floors, the distance from the equator, these all shape how the tide behaves. In narrow bays, the water is funneled in and out with surprising force. In wide open shores, the tides are slower, more stretched. Some places see tides rise meters high, others only centimeters. But even when we don't see them, the tides are there, quietly breathing, shaping the sand beneath the waves. And just as they shape the shore, they shape us too. Perhaps this duality, this rising and falling twice each day, mirrors something in us. The ebb and flow of emotion, the rise and retreat of energy, the closeness and distance of thought. We too are pulled by forces seen and unseen, drawn near by connection, then pushed outward by independence. We live in tides, not only of water, but of time, too of attention, of feeling. And that's what the tides remind us, that it's okay to rise. It's okay to recede. It's not a failure to pull away. It's not weakness to return again. It's just the rhythm of things. So tonight, as your breath moves in and out, let it echo that rhythm. Let your thoughts rise, then fall. Let tension swell, then soften. You are, after all, mostly water. You are moved by the moon, more than you know. And somewhere out there, the sea is doing the same, guided by a glowing presence above, gentle, constant, quiet, pulling you back toward rest. Let's begin with time, not the kind that ticks loudly on a plastic wall clock, but the quieter kind, the kind you feel, more than hear. Time that moves like shadows across a floor, like the hush between waves, like the way you know it's late, even when you haven't looked at the hour. Tides live in that kind of time. You may already know this. There are 2 high tides and 2 low tides in most coastal places each day. But the tide doesn't return at the same time every morning. It drifts forward about 50 minutes later with each passing day. And this this gentle drift, is no mistake. It is, in fact, the rhythm of the moon itself. You see, while Earth spins on its axis once every 24 hours, the moon is not fixed in place. It's orbiting, slowly, steadily, around our planet. Each day, the moon rises roughly 50 minutes later than the day before, and so the tide follows. The ocean is not setting its watch by our schedules. It is keeping time with the sky. Imagine waking up near the sea every morning, not by alarm, but by the sound of water returning, and noticing, quietly, that it comes just a little later than the day before. A soft reminder that nature does not rush, that even something as massive as the sea adjusts, responds, waits. This lunar rhythm, this 24-hour and 50-minute tidal cycle, means that high tide isn't pinned to our human clocks. Instead, it slides slowly through the hours. High tide at 6 a.m. one day to become 6:50 the next, then 7:40, and onward. It's a drifting rhythm, one that demands attention, observation, patience. Fishermen know this well. So do sailors. So do those who live by the water, those whose lives are shaped by the movements of the sea. And yet, most of us, to go about our days unaware that this grand celestial schedule is unfolding beside us. The moon moves, the sea responds, time slides forward, and the world keeps turning. Let's go deeper still. This delay, this daily shift, isn't just poetic. It's mechanical. It happens because, as Earth spins once every 24 hours, the moon is also drifting eastward in its orbit around the planet. So each day, Earth must turn a little farther to catch up to the moon's new position in the sky. That extra rotation, about 13 degrees more than a full turn, takes about 50 extra minutes. So the tides wait, not because they're late, but because they are loyal. They follow the moon. Now pause for a moment. Let that image settle. The idea that massive oceans, to wait for a celestial body, that salt water, tunes itself to something millions of times smaller than itself. There is something humbling about that. To think that timing, this most human of ideas, is actually lunar at its core, that long before clocks or calendars, there were tides, marking time, with motion, with memory. Many ancient cultures knew this. They marked time by the moon, by the water. By the way, both would shift and return again. To them, the tide wasn't just a physical phenomenon. It was a message, a measure, a rhythm to live by. Even now, modern tide charts are written not by the hour, but by the moon's position. And that brings us to the beauty of unpredictability. Though the tides are consistent, they do not always rise to the same height, nor do they arrive at precisely the same time from week to week. Why? Because of the Sunday. Yes, the sun, too, has its hand in the ocean, not as dominant as the moon, but still a player in this grand ballet. When the sun and moon align, during new moons and full moons, their gravitational pulls combine. The result is a more extreme tide. Spring tides, named not for the season, but for the idea of leaping forward. These tides are higher and lower than usual. A stronger inhale, a deeper exhale. And 2 weeks later, when the moon is at a right angle to the Earth and Sun, their forces partially cancel each other out. These are neap tides, quieter, gentler swings. Not every tide is the same. Not every moment is peak. And again, we're reminded, timing matters. Not just to the ocean, But to us, there are days of motion and days of stillness, days to rise and days to rest. The sea doesn't judge itself for not reaching the shore. It doesn't strive to be at high tide all the time. It knows when to pull back, and it waits for the right moment to return. So maybe we can learn from that timing. Maybe your tiredness today is just a low tide. Maybe your energy, your creativity, your hope, they rise again in rhythm with something larger than you can see. And that's okay, because rest is not the opposite of progress. It is the preparation for it. Tides don't need to be loud to be powerful. They don't need to rush to be right. They just need time. Let's bring it back to your breath. Take one now, slow and quiet. Let it rise and fall. And again, feel how even your own body has tides, waves of breath, beats of heart, rhythms that don't follow a clock, but a feeling. And as you lie here, allow your thoughts to drift, not forward, not backward, just outward, like water responding to the moon, because you, too, are in motion, even in stillness, even now. So sleep, like the tide returning, like time letting go. The moon is watching, the sea is listening, and everything is exactly where it needs to be. Take a breath, settle in, and picture this: a still night, a wide field, the hush of wind brushing gently over grass. You tilt your head back, gaze into the sky, and above you it shimmers. The stars, dancing, flickering, like candle flames caught in a gentle breeze. But not everything up there sparkles. You notice it, a point of light, bright but steady, not flickering, not twinkling, just calm, unmoving in its glow. That light is a planet, and it's trying to tell you something. Not in words, not in science yet, but in stillness. Because while stars dazzle and blink, planets watch, quiet, unwavering. Tonight, we explore why. And in doing so, perhaps we'll uncover not only a cosmic truth, but a quieter lesson about perception, proximity, and presence. Let's begin by remembering what twinkling really island. You might recall from earlier, stars don't actually twinkle. Their light is constant, steady, unchanging as it travels across unimaginable distances. It's only when it reaches Earth's atmosphere that things begin to dance. The air above us is not still. It's full of layers, warm rising, cool sinking, winds shifting, moisture floating. These tiny ripples in the air bend and scatter the light from the stars. What reaches your eye is a constantly shifting beam, like sunlight through water. This we call atmospheric scintillation, or, more gently, twinkling. But not everything in the night sky twinkles. Not every light is bent and tossed in the same way. And here, we come to the difference between a star and a planet. Stars are distant, incredibly so. They are suns in their own right, burning across the galaxy, many light years away. Because they are so far, they appear to us as points of light. Even through most telescopes, a star is just a pinpoint, no matter how bright. And a point of light is especially sensitive to the distortions of the air. Even a small ripple in the atmosphere can make that tiny beam wiggle. That's why stars flicker. Now shift your gaze to a planet. It may be hundreds of millions of kilometers away, but compared to the stars, it's practically in our backyard. Mars, Jupiter, Saturn, They live in our solar system. They orbit the same Sunday. They ride the same gravitational currents that cradle Earth. Because they are so much closer, they appear to us as disks, not points, larger, wider, still small, yes, but wide enough that atmospheric distortion affects different parts of the planet's light differently. The result? The tiny shifts and bends tend to cancel each other out. Where one side of the disk wobbles, another remains steady. And so, to your eyes, the planet doesn't twinkle, it glows, calm, are focused, present. Let's pause here, not for a fact, but for a feeling. There's something beautiful about the idea that stillness comes not from being untouched, but from being close. A planet doesn't twinkle because it's near, because it's clear, because we see more of it, not less. It reminds us that clarity often comes not from mystery, but from familiarity, from attention, from presence. Stars, though glorious, remain faraway flames. Planets are companions. They don't demand your awe. They offer your reflection. Jupiter rises like a pale lantern. Venus glows low at dawn, steady and soft. Saturn lingers, its rings invisible to the eye, but its light unwavering. They each have their rhythms, their brightness, their movement across the sky, but they do not blink. And in a world so full of flickering, notifications, lights, thoughts, something that holds steady feels almost sacred. Let's shift our lens to the telescope. For centuries, humans have tried to tame the twinkle, not to eliminate the stars, but to see them as they truly are. Astronomers yearned for clarity, for an unbroken beam of starlight. So they built observatories on mountaintops where the air is thinner, less turbulent. They learned to use adaptive optics, technology that bends mirrors in real time, to correct for atmospheric wiggles. And ultimately, they launched telescopes into space. The Hubble, James Webb, floating beyond the blur, these instruments see the stars as they are, steady, ancient, precise. But even before all that, the planets were our first guides. Through even modest telescopes, the bands of Jupiter, the crescent of Venus, the icy rings of Saturn, they revealed themselves, because their light did not dance. It did not jitter. It was calm enough to be studied, to be known. And what can we learn from this? That sometimes what sparkles isn't what's clearest. That closeness brings steadiness. That distance, while dazzling, can also distort. There are things in life that flicker, not because they are false, but because they are far, and there are others that glow quietly beside you. They don't demand your gaze, but they reward it. Maybe it's the friend who listens more than talks. Maybe it's the small ritual that keeps you grounded. Maybe it's your breath, soft, unmoving, ever present. Let's return now to the night, to your room, still and dark, to your breath, slow and rhythmic. Outside, the sky continues to turn. The stars still twinkle, winking across the atmosphere. But somewhere in that tapestry, there's a point of light that does not blink. Look for it. It's there, holding steady, while the rest of the world flickers, a calm gaze in a shimmering sea. A planet. Maybe Mars. Maybe Jupiter. Maybe, tonight, just a metaphor. Something that doesn't need to change. To be beautiful. So as your thoughts settle, as your breath softens, as the stars slowly blink out, behind your heavy eyelids, Let the planets keep watch. Let their calm be your calm. And know that not everything needs to dazzle to be worthy of wonder. Sometimes, the light that doesn't twinkle is the one that stays. With you, settle in now. Let your breath fall into rhythm, soft, unhurried, and picture this: a long stretch of mountains, cold wind brushing across a dark ridge. At the peak, a dome, white and silent, like a sleeping eye. Inside, a telescope waits, a single lens, gazing into the deepest dark, not blinking, not breathing, just watching. Because when it comes to truly seeing the stars, not their flicker, but their truth, you need stillness, you need patience, and above all, you need time. Let's explore that together. Humans have looked at the stars for as long as we've had eyes to see them. At first with wonder, then with questions, and finally, with tools. Telescopes are those tools. But more than glass and metal, they are invitations to see farther, more clearly than our naked eyes ever could. But why do we need them? Why isn't starlight enough? Because the stars are distant. So far, their light is ancient by the time it reaches us. The light from the nearest star system, Alpha Centauri, takes over 4 years to arrive. And others? Centuries. Millennia. You're not seeing the star as it island. You're seeing how it was. The sky is a museum of light. Each point, a portrait from the past. And yet, our eyes blur. Our atmosphere shimmers. The stars twinkle. To sharpen that view, we build telescopes. Not just to make the stars closer, but to make them clearer. And that clarity is more than just focus. It is understanding. It is quiet. Let's begin with the refracting telescope. It uses lenses, much like glasses or magnifying glass, to bend light inward, to collect it, to sharpen it. Simple, beautiful, the kind Galileo used. Then came the reflecting telescope, using mirrors, not lenses, to gather light. Easier to build large, capable of peering deeper into space. Today, most observatories use massive reflectors. Light enters a wide opening, bounces off a curved mirror, and focuses to a fine point, one the human eye, or a camera, can study in stillness. But there's a problem. Earth's atmosphere, the same one that protects us, nourishes us, lets us breathe, also gets in the way. It bends starlight, scatters it, breaks it into waves. So astronomers climb mountains. They go higher, into thinner air, to reduce the flicker. Places like Mauna Kea in Hawaii, or the Atacama Desert in Chile, dry, high, dark, perfect for seeing the sky. And when that isn't enough, we go to space. The Hubble Space Telescope orbits far above the Earth, free from our atmosphere's shimmering veil. It has no twinkle to contend with, only the deep, dark stillness of space. With it, we've seen galaxies, born and broken, nebulae, like brush strokes. The light of the early universe, still reaching us, like a lullaby from before time had names. And yet, even on Earth, we keep improving. Adaptive optics is one such marvel, a system of mirrors that flex and reshape dozens of times per second to compensate for atmospheric turbulence in real time. Imagine a mirror that listens to the wind and adjusts. The result? A sharper view, even from below the sky. Less twinkle, more truth. But let's pause here. Because all this science, the mirrors, the lenses, the orbits, is not about the tools themselves. It's about the act of seeing, about longing, about reaching. Telescopes are human curiosity, made visible. A lens not just for light, but for time. To look through a telescope is to slow down, to wait for light that's travelled longer than we've been alive, to witness something you'll never touch, but somehow still feel. When astronomers stare at distant galaxies, they're not watching stars. They're watching stories, written in photons, whispered across space. A twinkle might distract, but a clear gaze, steady, soft, tells the tale. And maybe that's the lesson. In life, things flicker. Ideas, feelings, memories. Sometimes, everything seems to sparkle and shift, leaving us unsure. But the science of seeing reminds us, when we want clarity, we don't look harder, we look slower. We remove the noise. We rise above the shimmer. We wait. Just as telescopes do. Let's try something. Close your eyes. Breathe. And imagine looking through a telescope. At first, you see the blur, the distortion, the flicker. But then, to adjust, focus. The blur settles. And there is Saturn. Its rings, graceful, impossible, and yet real. You don't need to understand every atom. You just need to see it. To believe it's there. Sometimes that's enough. Telescopes have taught us more than science ever expected. They've helped us measure the expansion of the universe, map the orbits of exoplanets, detect the dimming of distant stars that hint at worlds circling them. They've shown us galaxies colliding like dancers, black holes where even light disappears. And all of this, every image, every discovery begins the same way, with a single beam of light, trapped for millennia, finally released, captured by a patient lens, by a gaze that doesn't blink. So tonight, as you drift deeper into rest, know this: you are not just the observer, you are the telescope. You focus, you receive, you witness. The thoughts in your mind may flicker, but deeper still, there is clarity. There is you, watching, quietly. Let your thoughts fade, like the shimmer in the air. Let only the truth remain. A single light, far away, but steady. You don't need all the answers tonight. Just the willingness to see, to breathe, to wait, like a telescope in the dark, waiting for the sky to tell its story. Let's begin with a breath. Soft, slow, like a star's whisper, slipping through the dark. Now close your eyes. Imagine the sky above you, the same sky you've known since childhood. A canvas of stars, each one blinking and twinkling, flickering like a secret you almost understand. But what if we told you the twinkle you see is only part of the story? What if there's another world of light, invisible, constant, moving just beyond the reach of your eyes? A universe of brightness you've never seen, but that's always been there. Tonight, we drift into that unseen world, into the wavelengths that lie beyond the visible. Let's go back to something familiar. Light. What we call light is only a thin sliver of a much broader spectrum. The visible spectrum, red, orange, yellow, green, blue, indigo, violet, is the range of wavelengths that human eyes can detect. It's what paints sunsets, what dances in rainbows, what reflects off leaves and snow and skin. But outside that narrow band lies a vast territory of invisible light. Longer than red, there's infrared. Shorter than violet, there's ultraviolet. And beyond those, microwaves, radio waves, X-rays, gamma rays. These aren't science fiction. They're real. They're everywhere. They are light, too, just light you can't see. And yes, they twinkle too. The stars don't stop shining just because your eyes can't follow their light. In the infrared, they glow with heat, even when hidden by clouds of cosmic dust. In the ultraviolet, they burn with high-energy radiation, shedding layers of their life story into space. Through radio waves, they hum like ancient beacons, their signals carrying across the void between galaxies. Astronomers have built instruments to catch these invisible twinkles, giant satellite dishes that listen instead of look, mirrors cooled to near absolute zero that catch the faintest glimmer of infrared heat. These tools don't stare through eyepieces. They translate whispers from stars, from quasars, from galaxies older than time as we know it. So what does a twinkle mean? In a world you cannot see, it means variability, movement, change. Even in the invisible spectrum, stars still flicker. Their light bends, scatters, and shifts as it passes through clouds, gas, and fields of gravity. They pulse with life. They echo through radio bands. They flare in gamma bursts. We may not see it, but it's there. And just because our eyes miss it, doesn't mean it doesn't touch us. Let's consider the infrared sky. You can't see it with your eyes, but you can feel it. It's the warmth of sunlight on your skin, the heat from a fire, or a breath in winter. Infrared light reveals stars in formation, hidden behind thick clouds of gas and dust. Where optical telescopes see darkness, infrared sees birth. It shows the soft glow of galaxies we thought were empty space. It tracks the gentle heat of exoplanets orbiting far-off suns. And in this warmth, there is twinkle. Not quick flickers, but subtle pulses, waves of temperature, shifted light, the cosmic signature of change. Now drift toward the ultraviolet. This is the light of intensity, of stars on fire, of violence and youth. Young stars shine brightest here, their fusion engines pumping out high-energy radiation that would blind us if not for the protection of Earth's atmosphere. And when these stars die, in explosions of breathtaking power, they flood the sky with invisible fire. Even in death, they twinkle, just not for us to see directly. So we send telescopes above the atmosphere, space-borne sentinels that can capture the ultraviolet shimmer of dying giants. They don't blink like the stars you see in the sky. They blaze, they bloom, and then they're gone. But in that brief, invisible moment, a twinkle is born. What about radio light? It hums, it pulses, it arrives as waveforms, like whispers you hear through thick walls. Some stars send out regular beats, pulsars, spinning like cosmic lighthouses. Each pulse is a blink, a twinkle you can't see, but one you can hear in data, in sound, in code. And then there are the fast radio bursts, mysterious, single blips from galaxies far away. No one's sure what causes them, but they sparkle with mystery, a signal in the silence, a soft light that never reaches your eye, but that still exists, still real, still beautiful. Let's pause here. There's a lesson in all of this. Just because you can't see it doesn't mean it isn't there. Some things glow quietly beneath the surface. They don't ask for attention. They don't demand your gaze. They simply are. And when the tools are right, when the moment is quiet, you notice them. You feel them. You learn to see without seeing. So what does it mean to see a star? Is it just the flicker of light in the sky? Or is it the recognition of something ancient, alive, and speaking? Because a star, invisible or not, is always communicating through warmth, through waves, through rays and pulses and fields, and all of it twinkling, even if your eyes never catch it. So tonight, as you lie in darkness, I know that there are stars out there, twinkling in ways you'll never see. In microwave frequencies, in gamma radiation, in bursts of neutrinos and gravitational waves. And you, a being made of cells and stardust, lie still and quiet, bathed in their invisible glow. Let's go back to your body, to your breath, to your own invisible twinkle. You radiate infrared. You pulse with electromagnetic fields. Your heart is a quiet drum. Your neurons sparkle with silent electricity. You are glowing. Even now, even in sleep. Maybe the universe isn't so distant after all. Maybe the invisible twinkles out there mirror the quiet pulses within you. Maybe we're all part of the same unseen rhythm. So as you close your eyes, and the stars above begin to vanish from your thoughts, remember this: the light you see is only part of the sky. The twinkle you miss is still happening, still echoing, still reaching. And perhaps, in the silence of your dreams, you'll feel it. The glow just beyond your vision, the warmth just beyond your skin, the light just beyond the visible. Take a slow breath. Feel the softness behind your closed eyes. That hush, that stillness, that quiet stage. It's where the universe appears, not as it is, but as you perceive it. Because long before we built observatories, long before we mapped constellations or studied photons, we were seeing stars with our minds. And what you see, how you see it, even why a star appears to twinkle, depends not just on the sky, but on your brain. Tonight, we wander into a quieter kind of cosmos, the one behind your eyes, a realm of neurons and perception, of optical illusions and cognitive magic. Because twinkling, for all its scientific explanation, isn't just about light bending in the atmosphere. It's about how your mind makes sense of that light. Your brain, your beautiful, mysterious brain, is an artist. It doesn't record reality. It interprets it, smooths it, stretches it, adds emotion, memory, meaning, and sometimes sparkle. Let's start with the eye. It captures light, yes. Light enters the cornea, passes through the lens, and lands on the retina, a thin sheet of neural tissue at the back of your eye. There, millions of photoreceptors, rods and cones, convert that light into electrical signals. But that's only the beginning. Those signals travel down the optic nerve into the brain. And once inside, they are stitched together into a picture, a story, a sky. But here's the thing. Your brain never sees raw light. It sees patterns. It sees movement. It sees difference. And it loves contrast. The flicker of a candle, the shimmer of a wave, the sparkle of a star. That twinkle you see in the sky, it's partially created in your mind. The eye is not a perfect machine. It moves constantly. Even when you try to hold your gaze steady, your eye performs tiny, involuntary motions called microsaccades. These movements prevent your vision from fading or burning out in one place. But they also add motion. They jitter your visual field just slightly, especially for small, bright points, like stars. Add in atmospheric distortion, and the result becomes a dynamic little dance, a point of light that seems to flicker, not because it truly does, but because your brain is tuned to notice that shimmer, to amplify it, to make it matter, because movement draws attention, and attention was once survival. But even beyond the eye, your mind contributes more. Have you ever stared at the stars on a perfectly still night and thought they moved, that they pulsed, drifted slightly, or brightened without cause? That sensation isn't the sky, it's your brain. In the act of expectation, you expect stars to twinkle, so your mind sometimes provides a little twinkle of its own. This is called top-down processing, where your beliefs, expectations, and memories shape how you interpret the world. You don't just see what's out there, you see what your brain is ready to find. Now let's drift deeper. Have you ever looked at the stars long enough that your vision begins to ripple? That the whole sky feels like it's shimmering? This effect, subtle, mysterious, can occur in low light, in fatigue, or in moments of deep relaxation. It's called visual noise, and it's part of your brain's way of filling in the blanks. When there isn't much information, as in a dark sky, your neurons begin to fire spontaneously. Tiny sparkles, little bursts, static. Most of the time, you don't notice it. But when you stare at the stars, sometimes the twinkle comes from within. Let's wander now into dreams. In REM sleep, your brain is active almost as much as when you're awake. And yet, your eyes are closed. No light, no stars. Still, you may dream of galaxies, of constellations, of sparkles and orbits and wonder, and none of it came from the sky. All of it, twinkle included, was imagined, built from memory, painted with emotion, constructed from the language of neurons. Your brain doesn't stop twinkling just because your eyes are shut. Sometimes, it shines brighter in the dark. So here's something to consider. The stars twinkle because of space, because of light, because of air, but also because of you, your biology, your perception, your wonder. You bring the twinkle to life. And not just stars, music, laughter, the way a candle flickers in someone's eyes. You don't just see beauty, you help create it. And there's something deeply comforting in knowing that even in a universe of objective facts, you're still part of the interpretation. You still add the sparkle. Let's take one last moment to lie back, to imagine the stars above, and to feel them not as distant suns, but as pieces of a painting your mind assembles gently, night after night. The stars don't twinkle on their own. They twinkle because you're here, because your brain noticed the shimmer, amplified the rhythm, held onto the feeling. Twinkle, you see, is not just light. It's perception. It's softness. It's a gift. And tonight, it's one your mind gives freely. The stars are still above us. Even now, as your eyelids grow heavy and your thoughts soften into stillness, they are there, flickering, blinking, dancing gently, like the hush of waves against a moonlit shore. And maybe you're wondering, after all we've explored, light and air, telescopes and perception, the invisible and the imagined, why does any of it matter? Why should we care? That stars twinkle? And tonight, in this final moment of wakefulness, we ask not the scientific question, but the quiet one. What does a twinkle mean to the human heart? Let's begin not with science, but with memory. Think back. Can you remember your first night beneath a sky full of stars? Maybe you were a child, wrapped in a blanket, pointing upward. Or maybe it came later, on a night drive through nowhere, window down, eyes full of sky. What did you feel? Was it awe? Fear? A quiet joy? That sense, that soft overwhelm, is where twinkle matters most. Because twinkling, in its deepest sense, is a language, not of facts, but of feelings, of being small and still, being part of something vast. The stars remind us that the universe is in motion, not just spinning galaxies or orbiting planets, but light itself, bending, stretching, changing. Each flicker in the sky is a sign of distance, of atmosphere, of perception, but also a reminder that everything is alive. Even the light that left its star 1,000 years ago is still dancing when it reaches you. There's poetry in that. That something so old can still sparkle. And what about us? We twinkle too, not in light, but in moments, in the shimmer of a glance, in laughter that skips across a quiet room, in ideas that flash like comets before fading into dreams. We are not steady beacons. We flicker, we change, we pulse and falter and shine again. Twinkle reminds us that we don't have to be constant to be beautiful. Let's think about the earth for a moment. The atmosphere, that veil of air we breathe, is the very thing that causes stars to twinkle. Without it, they'd be steady. But we wouldn't be here. The same layer that blurs the cosmos also holds our clouds, our rains, our songs carried on the wind. The imperfection is essential. The wobble makes life possible. The twinkle is a side effect of being alive. And maybe that's true for more than just light. Maybe the flickers in our own lives, the uncertain steps, the moments of blur are what make us real. Let's step back. Imagine the stars again. Countless points of light, each twinkling in its own way. Some blink quickly. Some seem to pulse slowly. Some don't twinkle at all. Each unique, each part of a greater pattern we barely comprehend. But together, they make the sky. And maybe that's a way to see humanity too. You twinkle differently than I do. Some days, we flicker with energy. Others, we barely glow. But we're all light, shaped by atmosphere, by distance, by memory. And when we come together, even silently, we become constellations. Let's linger on one more idea. A star's twinkle is a sign of distance. The farther away the star, the more its light bends and dances before it reaches us. And in that, there is longing. Twinkle is what happens. When we reach for something we can't quite touch, it's the shimmer of the unreachable. And yet, we keep looking, we keep wondering, we keep dreaming. Twinkle reminds us that some of the most beautiful things in life are the ones we can't hold, only watch, only feel, only imagine, and that's enough. So now, as your breath grows slower, as your thoughts soften like dusk, let this be your last reflection. The stars do not twinkle to get your attention. They do not perform. They simply shine, and let the world do the rest. It is the atmosphere that shakes their light. It is your mind that perceives the sparkle. The twinkle is in the connection between what is and what is felt, between the ancient and the immediate, between a point of light and a heart that notices it. As you lie there, wrapped in stillness, wrapped in time, know that the stars are still above you. Know that their twinkle is not an imperfection. It's a sign of something real, traveling far to reach you. And that, in its own way, is love. The light was never meant to dazzle, only to arrive. And tonight, it has. So, close your eyes and let the night take you. You don't need to understand everything. You don't need to hold the stars in your hands. Just let them flicker. Let them shimmer. Let them be. And in doing so, so will you. Sleep well, gentle dreamer. You are made of stardust, and just like the stars, you twinkle too. Good night.